middle of our discussion, I've been trying to put together a list of like next steps that I want to work on with the exchange team to see like where should we improve telemetry? What kind of data do we want to get back? Do you have any requests?
One of the things that is missing for me is indications of packet loss rates and packet loss patterns.
What exactly what are you looking for in terms of packet loss patterns?
So my theory is that if you do like the head of line blocking removal stuff, right? If you only have a single stream going on at the same time, you don't win anything. So you want multiple streams at the same time. But if you multiplex them, let's say per packet round robin, and you have a burst of like 10 packets, all of your streams will still have packet loss and you've gained nothing. So you want to do not per packet, but slightly less fine-grained. But how much do you do? That depends on your packet loss patterns. So the burstiness, basically.
How would you boil that down to like a telemetry? Like if you're looking for a number or percentage, like how would you represent that other than I want to grab 1 billion traces and just peruse them and try to glean some kind of information? Pretty much at this scale, I have to figure out how to boil it down to a number or it's not practical.
A number of consecutive packets that were lost. Like
so you're just saying
if you detect loss, is it 1 or 2 packets, or is it always like 10 to 20 packets?
Do you want like the average packet burst or packet loss burst size?
Yeah,
like
basically.
Okay.
Well, average, minimum, maximum, P, and so on, of course. But that would be like one metric. That would be.
But is that really the right metric there? Isn't the one is number of affected streams by a burst?
Well, yes, but the number of affected streams depends on your multiplexer used. And I want to know what the burstiness is so I can run new experiments with different multiplexers to see how well they perform on, right? So
okay, depends on if you already have some multiplexing, yes, it would be.
I fully agree. But I'm thinking long term. I want to do a paper on this, right?
I could think about that. I mean, I could get some kind of like running average per connection that says like how big, what's the burst size of packet loss. I could collect that probably. Be a little tricky because well, maybe not. You could do it like per ACK. What was the largest or how many packets were lost?
And then you still need to correlate with the size of the ACK. So if you have that as well, of course, like the average size of the average ACK and then the average amount of packets lost per ACK and so on.
Yeah.
And then ideally you would also have like interburst times. You know what I mean? Like how long between big packet loss bursts is there? Like, are you seeing big bursts every RTT? Are they every 10 RTTs?
That's gonna be hard because then I imagine that's so dependent on the traffic pattern. If you're not limited by congestion control and you're just application limited, whenever there's app buffer, it'll burst, and that's the end of it. Because generally we're dealing with fairly small transfers, at least per request. I can't say currently with the data I have how many like average parallel requests are happening. I know just by looking in like the network viewer in Chrome or Edge, and you do a refresh or you navigate between browser, you can see lots of requests. So there's definitely parallel requests going on, but I don't have data that says how much parallelism there is.
Oh, interesting, because that's the second one I would, the next thing I was going to ask. If you would have that kind of telemetry, that would also be very useful again know, because if we know the packet burst size, then we still need to know how many streams do we have to work with and the relative priorities of those streams. Because it's really a balancing act between priorities and the scheduling and head of line blocking removal and but even just having the average burstiness would already be great to at least have an idea. Like, is it often just a single or two packets, or is most often is it like big bursts in between? And that would also be useful to know for other things like error correction coding and things like that, and probably also multipath and retransmission decisions.
No. I also wonder how much that's dependent on your scenario. And if for some reason you're sending just enough data that just barely goes over some middle box's buffer limit and you get one packet loss every time, what does that tell you versus maybe another connection that's getting larger requests or responses that has multiple going over that every time?
I fully agree, but at this point we have nothing. And having something would already be more useful than nothing.
I guess
if that makes sense.
Extreme here would be to try to capture some kind of version of a packet trace that has like packet sent times and packet act times and packet loss times or something like that. But again, like we get tens of billions of samples a month, and that's a little overkill, probably. I don't know what, and I also don't know how complicated, because that'd be a whole new system to implement on the collecting. And is it an issue that it's only one side? Because I mean, we completely control the server, but on the client, you're not going to get that kind of information.
No, but the server is doing the main sending either way, right? And it's the client that's going to be suffering from the head of line blocking most, I would assume. So server side would be most.
Yeah.
Like I said, because you're asking what would be useful, I would say think about it. If you come up with even half of what I asked, that would already be a big step forward. And hopefully, what I also hope is maybe some kind of convincing to other parties, other companies to share that kind of data.
Nick, are you tracking how often it's mobile networks that you have at the client side?
Let me see.
Because I mean, I think especially in this regards to saying bursts, I mean, mobile handovers is probably one of these reasons for burst losses.
Here, let me give you a little bit of a sneak preview or insight to some of the things, the knobs I've got to look at this data. So there's a lot of stuff here. I don't know if it works. Where'd it go? Can you see my screen?
Yes.
Okay. Like there's this client network type, egress network type. I am not sure how they do this, what they do. Here, let me go turn off IPv6 real quick. So the benefits when you work at a very large company with access to data like this, you can look at some of these things. So I don't know, let's look at this and let me filter to just HP3.
Graphics.
Takes a little bit sometimes. Sometimes this percentile is too high if there's not enough samples in the category, and it will complain. But let's see.
What would it take for us to get access to this kind of tool, Nick?
Besides
a contract at Microsoft.
I do not know. Most of this stuff isn't particularly sensitive, I think. Like things that are sensitive, they don't give us access to. I think some of these things that they'll have like client like all these things. There's
Cool.
was it client IP? There's actually nothing in here, so I don't have.
Mhm, mhm.
What is it taking so long for? I've never played around with this, so maybe. All right, let's try a refresh.
In the meantime, while we're waiting for that, we had a question in the chat from Abhinav. Maybe you can ask your question now while we're waiting for.
Yeah, hi. So I have a very basic question. So I've been trying to use various browsers with open source implementations like EPIQ, Quiche, and other implementations, and I've been successful using Chrome as a very like a matured implementation and easy to connect. Like if I try to use Microsoft Edge or Apple Safari, so I've not been very successful. Is there like a particular way, like in Chrome, I use like origin to force quick on as a command line parameter to connect to the server. So just wanting to like know if there is anything which can be done with other browsers.
And Edge should be pretty much the same. Whatever you do with Chrome, you do the same thing with Edge.
So like or like origin to force quick on something like this.
Probably. I'm not on the
Yeah.
Edge team, but I mean Edge is just using Chromium and modifying certain things. So that's pretty much just going to be the same, I'd expect.
In theory, yes, Abhinav.
Okay.
It might be they intentionally disabled it, but I really wouldn't know why they would do that. For Edge, Safari, as far as I know, has no way of forcing at this point.
Okay.
And
Okay.
neither does Firefox, sadly.
Okay.
So there you
So-
do have to go through the alt services.
So Chrome is the best option as of now.
Chrome or Edge should work. I mean, as you can see,
Chrome or Edge would work.
I'm using Edge. I use Edge for everything. And works just fine.
Okay. Okay.
Those
And
are-
anyhow we can generate like Q logs using a browser?
Sadly, no. But the Chrome generates net logs.
Yeah.
And QViz, which I think you know, right? The QViz tool
right.
suite that
Right.
can ingest net logs as well, and it transforms net logs into Q logs internally. So you can visualize net logs with QViz. It's not full featured. It doesn't do everything that a normal Q log will do from the server side, for example, but it should give you a lot to work with. And if there are things that you don't have, let me know. Open an issue or something, and then.
Okay. And there was another feature which I saw online, like PCAP to Q logs. So like, is it like matured enough to use that feature?
Similar to netlog to QLog. So you can upload PCAPs, but of course PCAPs don't have a lot of information in them. They don't have the congestion window. They don't have the round trip time measurements. It's just the pure packets, right? So you can, and you should again be able to upload that to QViz, and it should work. And if it doesn't, let me know.
Okay. Thank you. Thanks a lot. That's all I had. Okay.
All right.
Yeah.
Thanks.
I don't quite believe this highlighted group. I'm one, who is using dial-up? Two, how do they figure it out? And three, why is it like the second fastest of all? But what was it? Was it Magnus? Was it you who asked for some of this data? So
yeah, or I was saying we have to wonder. I assumed that you could do what you had, that you had the classification for cellular, and it seems fairly, I think, realistic that the higher, there's a lot of samples, and it's I guess it's one of the worst when it comes to the real end tail, and that also makes sense.
yeah.
So
yeah, and I would still classify it as not too bad, at least when I'm comparing to the HTTP2 data that I see, which is just absurdly huge. It's still not too bad. But yeah, I agree.
Yeah.
And it also makes sense. But The so-called corporate networks look to be the best.
Yeah, I mean,
So
I
if-
assume that this is they're probably picking that up from the IP ranges it's given to certain companies, etc. I guess. I wouldn't be surprised if that's how they do it. I mean, at least larger corporates has their own ASs. So
Yeah, I agree.
no.
But so yeah, if you could have like the packet loss stuff split out roughly by this kind of thing, that would even be better, right? Then you would know it's much more bursty on cellular, or vice versa. It's much more spurious, or just 1 or 2 on cellular, or and much more bursty because it's more buffer bloat on the wired connections, for example, right?
Yeah. So how a lot of this works, at least on the server side telemetry, they snapshot, because a lot of this stuff is going to come down. It's not necessarily per request data. It's actually connection-wide data that you can snapshot before the request starts and after the request ends. And you can get an idea of what happened during the lifetime of that request, but that doesn't necessarily mean it only happened for that request. So for instance, if we had a running, or just the running total number of packets lost, you can snapshot that before the request and after. But if there could have been 100 parallel requests that happened in that time, they might all see, oh, there was a delta of 35 packets lost between this. So it's kind of hard to use that in a useful way. Maybe you can just say, hey, once I'm dealing with 1 billion requests, it all is hopefully just going to average out, and it just works. And sometimes it works when you're dealing with data on that scale. I don't know, and I'm not quite sure how you can reason about that to say, hey, how many does the total number of packets that were lost during the lifetime of this request help you or not?
Again, if you correlate it to the total amount of packets sent, received, or X
Yeah,
sent,
I mean,
received, then
we could
it's
give
still
that, like,
useful.
for every request, how many packets were sent during the lifetime of that, how many packets were received during the lifetime of that, how many packets were lost or suspected lost, at least during that.
Exactly.
I think that's information we already collect. It just hasn't been integrated into this system yet. But yeah, so that's something. I've got a meeting with the Exchange team today, might discuss some of this stuff. So as I said in my presentation, we're really just scratching the surface here. And we have
exactly
functional, we have some data. We're trying to understand what we have, trying to figure out what questions to ask, and then figure out what data we need to be able to answer those questions.
So I had a question. Can you hear me okay?
Yeah, we can hear Lucas.
Yeah.
Cool. Yeah. I'm working from bed today because of logistical reasons. So I'm on not my nice setup. So I missed a bit of the start of your keynote, sadly, Nick. Sorry about that. But the question I had is that around Outlook Web App, like what do the HTTP request flows look like over a session, say, where like, and so part of this is, for instance, like a user opens up a browser for the first time in a month and hits Outlook Web App to read some emails or whatever, like, is that going to go to H2 first and then jump up to H3 because of alt service? And then how long does that alt service last for? And like how sticky is that client going to be to using Quick for as long as it, Quick works on the network?
So right now, the primary client we're focused on is the browser. So a lot of those questions have to be answered by the browser. Obviously, the stickiness of alt service depends on the expiration time. I don't remember what Exchange was putting. I think it was at least 24 hours. That might be what they were setting. Assuming you're within that 24-hour period, is the browser expected to try HTTP3 first when it reconnects? or is it always going to go through the alt service? I'd expect it to try HTTP3 first.
Yeah. And so like for the, because unlike a web page where you might load it and navigate around a bit and then, you know, that's kind of the end of things.
Mhm.
You know, these kind of office apps might want you to stay online a bit more, right? So that they can push you notifications that an email just arrived and
Yeah,
stuff
so
like that.
no, not this one. So I do define, they are long-lived connections. They essentially maintain keep alive at the application layer to keep it alive forever. We get at least, from the data I've seen, like a 200-to-1 ratio between like new connections and requests. So you get a lot of requests over a single connection. But yeah, it maintains those long-lived. I don't think they ever expired on purpose. So it's just a matter of how long can it stay alive before something gets disconnected, the browser gets paused or something, and it just kills it. Or at least that's at the application layer, at the server layer, whatever the browser does, we don't have complete control of that either.
Yeah, that all makes sense. I think, you know, unlike other kinds of web page too, you're going to have a lot of dynamic content that you can't just cache in the browser. Like, you know, the Chrome of the page will get cached most likely, but yeah, you're not. It's just, you know, my experience. You load a web page and you reload, and you maybe make, you know, the first load was dozens of requests, and a reload is like one, right? So it's like the whole HB3 and multiplexing is immediately neutered because most of the page was loaded over TCP to start with anyway. Unless you do a revisit, at which time your alt service is probably expired anyway compared to your cache, and like it's all a bit annoying. But without being able to log in to these services, I can't experiment. So hence asking you.
Yeah, now we're just discussing. So I'm for instance, let me see what happens when I refresh. But my browser seems to have just hung. Come on. Great. Something just died in the browser. Bad demo.
It's Microsoft technology. I mean, never works.
Well, for this, I'm what 95% of this is all Chrome, so I don't know.
It's Edge. It's Edge. I mean, it's still Microsoft.
Did
Try
old
again.
Edge ever get as far as trying to use Quick at all?
No,
Edge. Huh.
Yeah. So it's like
it didn't.
4 years ago now that it switched almost.
Oh, that's a lot. Whoa. What are those JavaScript files doing?
800 requests.
Jesus.
So
that is Microsoft software though.
So I mean, like I said, we get a lot of samples. There's a lot of requests that happen, but you also have to see, like, it's only to. I'm using an internal version of the site, as you can see, evergreen thing. But it only the Outlook.office.com has HTTP3 deployed. Any other, there are a lot of CDNs involved that are H2 or 1.1. But yeah, so all these CDN things, I don't know what they are. But yeah, there's plenty of stuff that happens. All right, well, good workshop, Robin. Thanks for inviting me.
Thanks for being there. Again, I'm very, very happy with how it turned out, even though we didn't have a huge amount of attendees. So I think it was very nice, and I'll do at most best to get the keynote up on YouTube or somewhere else, and I'm sure that will generate much more views.
Yeah,
Down the
yeah.
line as well.
I had a number of people already asking for a link once it's available.
Yeah. Exactly. So, and I really liked the whole keynote. It was very good data, and like I said, very nice how you drill down into the separate slices of the data, trying to find where things are coming from, and then also showing that you don't really know for some things, so that we still need more.
Yeah.
Which is always great. Yeah.
It's great. I you know, we have ambitions to talk more, but whatever, the powers that be make it hard. So when other companies are doing it, it's great to show them and say,
Mhm.
here's a good way to present data, or you know, here's a question that maybe we can work together as a community to try and do more. That's what I was like trying to say. Like, there's things that are good to work on, but we don't have the time. So like, if researchers can go and do that, it's amazing. Like if they can present that in some way or something, but I don't know. We're all quite
Yeah,
busy. So
And with us, and we have the opportunity to, researchers could theoretically make a change to MSQuick that say like on the different MTU discovery algorithms, if they can add the ability to try different algorithms, we can deploy that to Exchange, run it, collect different
Exactly.
data, and report back the data after a couple of months after the change. So definitely opportunities for collaboration. So research work could actually generate real world production data and get that back.
Yeah, I'll probably try and make use of that. Down the line, definitely.
Yeah. Well,
That was great. The final thing I was wondering about, Lucas, because I know Cloudflare is one of the parties Apple is using to deploy the mask proxies. So you probably know some of the multiplexing prioritization logic they use, right?
I can't talk about anything related to anything. So
Yeah, exactly.
if you want to hear about Private Relay, you can speak to Tommy Pauly, who I hear gives good presentations about it.
That's at least confirming what I thought. Yeah.
But you know, the stuff we talk about in Mask, you know, the HP priorities draft I linked earlier, we have a section on Connect streams and how their prioritization needs are maybe different. You're familiar with that work. A lot of it is the signaling, but it's not really. Like I don't know if MS Quick has any quick layer prioritization. I don't remember if I ever looked at it, but like you're going to pick some way of saying one thing's more important than another, or that these should be split bandwidth like round robin, or what like that. So if you can translate this simple HTTP layer scheme, but between your quick and that, like it's so simple, it should translate easily. That's what we found with Quiche. Like we don't implement it verbatim. We have we have a number space from 0 to 256, whereas you know HB is only 0 to 7, and we do some things there. So you know, the whole thing with datagram too, you can use the combination of quick layer priorities to translate into scheduling and do things. So you know, Connect is a bit different because normally with HTTP, a request has some small-ish finite lifetime, and if you serve those like a dumb FIFO, they're gonna end, or they might not have data to transmit that's readily available. Whatever. Connect's weird because as a proxy, you just don't know what the server is going to be sending you, so you could easily block everything. Like what Miria was saying sounds like AI
Exactly.
is dumb, and yeah, like you should absolutely avoid that. So but if you were to do HB signaling here, the draft says mark them all as incremental, and then an implementation can round robin if that's what it chooses to do with the signal. Datagram comes from discussions where people wanted us to consider how to prioritize that and put it in the datagram draft, but it's too new. I don't think anyone's got enough implementation experience to say. So it's more like you can prioritize them, and you probably should if against each other, like multiplex flows, or all things, but we're not going to say how to do it here. Oh, we're not going to say how to do it in HTTP3 datagram. We're not going to say how to do anything anywhere, but just pretending it's really important. This is kind of sucks.
Yeah, I mean, for our proxy, if we just had to implement, or if it's actually just behaved that it was like dealing with the thing in reception order, it would have been, you would have no special prioritization. It would be like, okay, it behaves like a link in most cases, a FIFO queue. Yeah, we would have avoided a lot of those kind of strange issues you would have with this in the stream mode there. And I mean, and that's what shows up in datagram, because that is behaving much more. I mean, that's as it's writing there. You take all the reception packets for all the streams, and just write it to one common output queue. So there we get that, because it's written at reception processing time. So then we would just have that behavior. But I mean, yes, getting that to behave like that for streams. I mean, yeah, it's not. You need to write a little bit of code and dealing with the packets, etc. I'm saying, okay. So
and also speaking to David around some of the stuff that they found with web transport and the different kinds of things that they've done, where the web transport W3C people needed to pick an order of like when you as a client app in the browser need to send you know, a high bandwidth flow of datagrams and a high bandwidth flow of streams. What do you do? Which one's more important? You know, toss a coin, pick one. Whatever, literally whatever you pick is going to be the wrong answer for some kind of app.
Yeah.
So like they've really punted on the client side prioritization. Like this is the, can I have a local API to control my app, not the signaling between peers. So that's not something I would try and tackle right now, because it's hard. But
yeah, I'm not convinced Quick ever needs signaling between peers as far as it, and APIs as far as like, okay, if you want to prioritize certain things a certain way, and that makes sense in the implementation of the API. But most applications I don't think would ever need any signaling API. And the ones that do, they might all want to do it slightly differently and leave it up to them. I'm having it in HTTP already will accrue to lots of different applications, since most applications or many applications out there are on top of HTTP anyways. So that's a good place to say, hey, let's do it there, and that can benefit a lot of different things. But I'm not convinced it needs to be at the Quick layer. Like signaling.
I don't know, the HTTP one is really focused on a client telling a server what to do, because that's the main direction of traffic. It's not the only one, right? But you know, there's been some discussion in the review the last week or so about, well actually H2 let servers send priority frames to clients. What did that mean? Like, did it? Oh yeah, it did. Oops. I've never heard anyone using that, so let's pretend it doesn't exist. Like
and sometimes you have to have things driven by actual scenarios. There's only so much I feel like you should do to try to design it and see if they will come. You need people to come and say, I need this. I have this requirement. The server needs to drive priorities. Do you know of any application, networking application, where a server needs to drive a priority? If you can't think of one, then maybe it's a problem that we don't need to solve.
Yeah, I don't know. Like for web browsing, it makes sense because it's like that waterfall is so touchy to different permutations of loading stuff. But for a server that's handling concurrent uploads of large files, like you probably know better than me, Nick. Like what does SMB do? Like it just handles them, or it's writing to some backing store, and effectively your flow control is kind of handling your back pressure is handling the priority that the client can send it at.
Yeah, usually at that point, if you're just trying to do a bulk transfer, priority doesn't really matter. You just want to fill the pipe. So yeah, maybe you've got flow control, because when you're SMB, you've got not just the network, but you've got disk IO. So sometimes disk IO might be the bottleneck if flow control. It's interesting, a lot of times your network can write faster than you can buffer. So you might have some really big buffer, but if you're writing to a hard drive, then all of a sudden that's the limiting factor. Maybe if you're copying multiple files to different locations, a hard drive and a solid state drive, flow control will allow those to progress at different speeds. But yeah, it's pretty much just the first come first serve is what I'm pretty sure for SMB, at least SMB over quick, they're just gonna shove it all in and we'll send it as fast as we can. It doesn't really matter when it gets there, as long as it all gets there as fast as possible, kind of in total.
A slightly tangential question. I mentioned to you.
I'm sorry to interrupt, but I really need to start going.
Okay.
Thanks again all for joining. Excellent day. I'm very happy you all would join us and give your time, precious time to me.
Sure.
Workshop. Yeah. Have a good time continuing discussing. And the last thing I wanted to say is Magnus, that is an awesome board gaming collection in the background.
That's just the overflow.
Yeah, probably. I can already see Everdell and Dune and all those things. So it's
yeah, but this is just
excellent.
the overflow. So
all right. Bucket list sometime, visit Magnus and play some board games. Okay.
Yeah.
Bye-bye, Robin.
Yeah.
Guys, see you next time. Bye. Thanks again.
So what was your question, Lucas?
I presume we're going to get kicked out when Robin closes the session.
No. I can assign a new host. So I will assign Nick, and it should be fine. All right. See you later, guys.
Bye, Robin.
Yeah. So I said I got an Xbox the other day, and I just wondered like how much of the stack, the network stack, that like it uses you're responsible for. But related to like obviously games are huge downloads now of like tens of gigabytes and stuff. Like, what do you know how that's transferred? Like, is it SMB or is it just HTTP download?
I believe so. I know on the Windows Store, so I think it's HTTP. I know it's not quick or anything right now. And like we've done additional work to use the LEDBET congestion control protocol, if you know about that. So essentially allowing it to download in the background and not impact the rest of your exchanges. So the Windows Store does it. I don't know how much conversion there is between Xbox Store and Windows Store. Those things change, I swear, like every year, or they well, we're going to do something the same, then we're going to do something different. But it's not going to be SMB. So SMB has problems over the internet. That was actually the primary reason they added quick support. For no actual quick features, the only reason they wanted quick support initially was so they could reach the internet. It can multiplex the port with HTTP. So HTTP and SMB servers can listen on the same port. And ISPs or firewalls or anything will have a very hard time blocking just SMB without also blocking HTTP. So before that, practically it wasn't used on the internet. So I suspect it's an HTTP-based download. It's either that or a custom TCP protocol.
Cool. No, that makes sense. I was thinking like, so I got Xbox Game Pass on PC and Xbox. So I'm not assuming they use the same download mechanism, but I could probably just PCAP it and see what's happening on my Windows box easily. But
I say there's a 50-50 chance that they're using the same thing. Like I said, over the years, things have changed and they've tried to converge the different things between Windows and Xbox. Because obviously, if you download a game in the Windows Store and you can download the same game for Xbox in the Xbox Store, it seems a little silly to duplicate all of that and have different protocols, different servers, different clients. Now, that doesn't mean it doesn't happen, but I would hope they have finally progressed to a place where there's a single server source, so a single protocol, maybe different clients, I don't know. But yeah, I don't know for certain.
I'll go and investigate. It's always fun to like look at Steam downloads as well and
Yeah.
see.
Oh,
which-
don't talk about Steam's download behavior. Even if I think it's become better, Steam was very good at grabbing bandwidth.
Yeah,
It always comes down to like knowing exactly what you want, what the user wants is difficult. Does the user want to say drop everything else and download this game, or do they want to just have it happen in the background? There should be like a download now button and a download slowly button, and then you can figure it out.
Yeah, but I think Steam has worked quite a lot in the app on this, and you also, I mean, you can configure bandwidth limits, so you can tell them to not use all your downlink bandwidth.
it used to do annoying stuff like pause the download while I was playing an offline game. You're like, no, that's the last thing I want. The reason I'm playing a game offline is because I'm bored. Like I'm waiting for the download of the thing I really want and trying to fill out the time.
Yeah, but that's yes, it's the default behavior, I think, to pause the downloads when you're playing to not affect the performance of the machine.
You waste an hour until you check like what's the progress of the download, 1%.
Yeah.
Sometimes.
You have to go play web games, browser games. No. Yeah. But yeah, I mean, Microsoft's download infrastructure, I think, is one of, I mean, that was been good for quite a lot of time. Even if I think it's a little bit, I haven't seen as good performance lately, but it's been one of these where like easily could fill my pipe even earlier, like 5-6 years ago.
I mean, you're in Sweden, so you probably have like 5 gigabytes down. Sorry,
No, I only have I have a limited 250 megabits.
What? I just upgraded.
Yeah,
to
there's no
500.
reason to pay for more. it's that diminishing return, and they charge way too much for that diminishing return. But because I mean, the number of minutes per year I would be able to would actually need to use anything faster than the 250 I have to go like the 1 gigabit, which is the link speeds. It's so little, and it would cost me so much. I actually rather spend my money on having 2 different connections for failover when I need it. It's not happening often, but I think it's happened like a couple of times this year. It's failed over. I have a not DSL. I have a DOCSIS cable as a backup. So fairly, it's like give me 300 megabits also downlink as a peak, but not in reality. Yeah. But about the priority, I was thinking about WebRTC and the discussion we had there and how difficult. I mean, they went with a fairly basic 5-tier priority, but it was. I have no idea if the relation between, especially for like SCTP, there was good enough. I think it was maybe 2 large steps between them, because they were basically saying that you would get double. For every, on 1 tier, you would send twice as many packets for the tier above it. So you would basically get, and the highest you would get, for every low priority packet, you would get 16 high priority packets, 8 in between in the level 4 and 4 of level 3 and 2 of the level 2 and only 1 then. So yeah, something like that. So
yeah, I don't really have many answers there. Like, there's never going to be enough, or there's going to be too many. The whole H2 priority thing was the perfect dream, because you could express the exact priority of stuff that you wanted and create groups of infinite size or infinitely small size, and that's brilliant, except for the fact that like it's really hard to implement that thing safely.
Yeah.
And no one could use it. There was no APIs to use it anyway. So what was the point? Like, just define some static groups, and it's probably going to be good enough.
Yeah, at least you can express that I much more prefer this over this. And I mean, the whole real-time media and WebRTC is an interesting. I have no idea really what the implementations does and how well it works. But yeah, you can express that 5 levels, the same 5 level tiers of priorities also for real-time media streams. But yeah, as I said in chat, they're separate congestion controllers, to my understanding in the implementation so far, until we get everything moved over to Quick, which I mean, eventually will happen at some point, but that means that the whole, how does real-time media over Quick behave well, so to say, and it's tough to deal with the codecs. They are a large part of this, which makes it hard.
Yeah. It's a shame we're not meeting in person to have these like deep conversations that are happening on the mailing list, over beers and stuff. Because the discussions are they're very interesting, but they're quite circular, and I don't know, it's kind of.
Yeah, I feel like some of them just require someone has to do something, try it, move forward, and it's probably not going to be the right thing. I can get some data. I'm beyond just one of these research things, and then we go from there. Say, hey, look, I did this. I shipped it. It works well enough. Here's some data, and then we can decide kind of as a group where to go from there. So I know at Microsoft there's a lot of different groups discussing this stuff. We have a number of different things that use video streaming and low latency stuff. So I will see where things go. Who goes there first? I mean, between things like xCloud, we've got remote desktop, we have Teams, a lot of different things that have video exchanging and other groups, all interested in this. Someone's going to do something, and then at least at Microsoft, and we'll figure out how things go from there.
Well, when you're happy to go public, let's add it to the mix of everyone else, like Facebook. It's nice having the idea of standardizing this, but I don't know, like if you can make it work for what you need, then why standardize anything? Like, if you were, for example, to use web transport to do some low latency remote desktop thing, like great, like the standards web transport, and it was flexible enough for you to try that out. Maybe you needed something more. Like, I don't know. I'm really interested to see what this Twitch thing is, because Luke Curley's been making lots of interesting comments on priorities and stuff. But it's hard to debate with people when you can't see what their protocol is. And if it only works for one use case, then it's not helpful, because like you might turn around and say, well, it doesn't work for me. I don't have a use case for this stuff right now, so I'm kind of just arguing philosophically, which is it's fun.
Yeah. Another benefit of being Microsoft, I mean, we've got a use case for just about every scenario. So you can find someone, probably half a dozen someones that want something. I've even talked to people in HoloLens, and they want to do real-time, like virtual reality streaming information. So essentially 3D streaming versus 2D. And so lots of interesting stuff going on. Various levels of, I think this is a cool idea we need to do this right now, and here's how we should do it. So we'll see how long some of these scenarios take to actually come to something. So, all right, well, I've got to drop. Great talking with you guys. Do you want me to transfer ownership to somebody else, or do you want me to just kill it?
No, I think we can kill it for me. I think, unless Lucas has something.